Alright, so compounded double angle formula, I'm pretty sure that we did this last year, because I can remember helping you with it, I think. Alright, so just some examples, 3 examples, I think. Yep, 3 examples. So one way we can, we can use our compound formula for is we can use, so if I want to find the exact value of something, say like 5 times 12 for example, 5 times 12 is actually times 6 plus times 4, so we can use this relationship and a compound angle formula to find an exact value. We want to find the sine of 5 times 12, for example. So when you look at the double angle formula, here we're adding together to get pi 12. You look at the sine, and there's sine x plus y, and that is sine x cos y plus cos x sine y, and you would then use, for sine 5 times 12, you'd use pi 6 plus pi 4, so it's the sine of pi 6 plus pi 4, which of course then make those substitutions here. So if we know the sine of pi 6 cos of pi 4 cos of pi 6, oops, and the sine of pi 4, we can put those values in, and then, so pi 6, I'm not sure I'll get this right this time. Alright, so the sine of pi 6 is a half, pi 4 root 2 on 2, cos of pi 6 is root 3 on 2, and the sine of pi 4 is root 2 on 2. So what we have is root 2 on 4 plus root 6 on 4, which you could put it over one denominator if you wanted to. Alright, so now we've found the exact value of sine of 5 pi and 12. It's not one of the ones that we normally would know, but by creating this addition of those angles, we can then use their exact values to help us. Alright, so we can solve some equation-y things. So for example, sine alpha, so alpha is some unknown angle, but we know that the sine of it's 0.6. And what else have we got? Alpha is between pi on 2 and pi, yep. And we want to find sine 2 alpha. So, double angle, sine 2 alpha, when you look at that, so sine 2x is 2 sine alpha cos alpha. And so we know sine alpha, we're given that, cos alpha we don't. Can we find it out? Can we find out cos alpha?
Yes.
By doing what?
Sine squared plus sine squared.
Thank you, sine squared plus cos squared is equal to 1. So 0.6 squared plus cos squared is equal to 1. So cos squared is 1 minus 0.36. So cos squared, for the alpha there, is 0.64. And so then cos alpha is the square root plus or minus the square root of 0.64, which is plus or minus 0.8. Now the question is, which one of those is it that we're after? Because alpha is in the second quad. Yep. So we want the negative. Alright, so cos alpha is negative 0.8. And so now we can stick those things, alpha, in here. Nearly forgot my negative. Got a negative answer. 0.96. 6 and 8's are 48. 0.48, 2 lots of that. 0.96. All right. Now, we can also use these formulas in a slightly different manner. So here's an example, last example.
I'm sorry. I don't understand. This is the bit on the video, I think.
But here you're given term 4 term, term 4 term 7. This is term 4 so it's that
All right.
7.
So here's another way that we can use double angle formulas. So given this is half an angle, you might think, how can we do that? So let's think about the double angle formula that links cos and sine together. So the one that links cos and sine together is cos 2x, and that is 1 minus sine squared.
So on back and given
X. Now, what we can do here with how we can use this to find half the angle is if we let x equal alpha on 2, and I've chosen that because we want the sine of alpha on 2, and here's the sine over here. So it'd be handy to get the alpha on 2 there, yeah? So if we do that, then we've got cos of 2x, so that's 2 times alpha on 2, is 1 minus sine squared, alpha on 2.
1 minus 1.
Now over here, 2 lots of alpha on 2 is 1 lot of alpha, and just so
And
happens
what about A?
No, no, it's not 13.
that we were given because of alpha up here. So 0.7, 1 minus sine squared, alpha on 2. Bit of rearranging, and then I would get that sine squared alpha on 2 is 1 minus 0.7. All good so far? Haven't made any mistakes yet. So then sine squared
Oh, that's 30.
alpha on 2
Yeah, you don't pay the same.
would be 0.3.
We don't?
So
Oh, I
that's
read
13, not 13. Yeah,
Can you read
I
that?
have made a mistake. The mistake I've made is there's a
That's 29.
2 in front of the sine squared.
Yep.
Isn't there? Yes? So, sine squared
Yep.
And then how funny.
alpha on 2 would be 0.15. So then, from that,
You just have to solve for it. It's like solving for x in the equation.
I don't remember how to do that.
So you just
sine then,
So a plus just 3 minus 3 is 9.
alpha on 2 would be plus or minus the square root of 0.15.
Thank you.
Question is, which one do we want? We want the negative because we're in the fourth quadrant. So fourth quad,
Yeah.
the negative sign we're after. So, what we need then, the sign alpha on 2 is the negative square root of 0.15, and then we need to get our calculator out for that.
Yeah.
And then that's point 387. Yes? Anything about any of that? No? All good. All right. Let's exercise 3B questions.